Hello everyone, welcome to our presentation. I am Ekin Kara, the leader of the team. As you can remember, our project was about mine and mineral identification mobile application. Today, we are going to show you our content overview about our project so far with my friend to you. Okay, let's start with the first title with my friend İnanç.
Hello, I'm İnanç from Atılım University's Software Engineering Department, and I will start off with the introduction to our project. If you tuned in to our previous presentation, you will have an idea about it. As a reminder, though, I'll tell you that the project aims to identify minerals through photos and reporting you its details and name. We hope it will be very helpful to mining companies, as most don't have this sort of availability, and as well as individuals who possess minerals that they want to know about. And since then, some time has passed, and we have carefully rethought and improved some aspects within our base design: data gathering, user interactivity, and as well as adding a new and fun feature.
Hello everyone, I am Esra, a senior student in information system engineering. I would like to talk about where we challenged and what we did. At the beginning of the project, we received support from a dataset on Kaggle and non-commercial online database like Mind.org to find reliable and sufficient data. However, considering the challenges encountered during the data cleaning process, we conducted a careful study to make the obtained data more reliable and meaningful. While overcoming these challenges, we aim to provide a more comprehensive experience by making additional contributions to our project, specifically by leveraging text-based artificial intelligence. We added new features to transform our project into a more interactive and user-friendly platform. Additionally, some parts have been corrected in non-functional requirements. We decided to manage our software development process using the Scrum methodology. This choice stems from our goal to make our project in systematic and structured framework. Our choice is based on Scrum focus on improving the ability to flexible adapt and uncertain requirements and improve through continuous feedback. Within our team, we have clearly defined specific roles. Our supervisor serves as the product owner, our team leader as the Scrum Master, and development team. To ensure good understanding and daily follow-up, we conduct regular daily meetings addressing one of the key goals of Scrum. To make our project process more manageable, we created backlogs specifying tasks to be completed within a certain time frame, such as 2 or 4 weeks, and organize them into sprints. We created prototypes, such as our interface design. We are successfully implementing the Scrum methodology, continuously reviewing the process of our project to facilitate ongoing improvements. Here you can see the plan of our project. We have adjusted each stage of this process to the date set by our supervisor and according to our own timeline. Completing all the steps up to this point, we are still in the development stage. We have outlined the upcoming stage. We will continue until our final report and representation. I will now hand it over to İnanç to explain the next part.
During the time between our SRS reports, we have also conducted a literature survey that let us see some key points within our project. The major two of those were that mineral identification as hard labor is extremely time-consuming and inefficient, and is prone to a human error of inaccuracy, which machine learning techniques mitigate much more. We also have realized that some of the techniques were pretty much in line with what we are doing. Image processing utilizing convolutional neural network to transform the image into data, deep learning methods ensuring ore estimation in an optimized time frame, data collection and analysis methods to allow gathering data to help identification and usability regarding user experiences and interface, focusing on design principles such as clarifying and minimalistic concepts.
Hey, hello everyone, I'm Çağlayan Demirci from Software Engineering Department. Let's continue with the literature review by UI and UX side. As you can see, in such applications, a screen appears for the user in order to take a photo. That photo screen is the key point of such applications. Generally, they are screen-wide and normally a focusing square, which is green, and taking photo button are there. After that screen, generally the user sees a simple information window after the process finished, and when it's time to explain what object the user took. Therefore, we prefer that to follow a similar interface logic.
In this section, we examined a similar application. We tested the application with a simple mic from our phone, and truly the result we obtained in detail. As a result of our experiments, we observed a system that ranks similarities in several possibilities. As seen in these photos here, it sorts from the most similar to least similar, which we believe may not provide a very efficient response. The application boasts a user-friendly and aesthetically pleasing interface. It is highly successful in terms of color harmony and user experience. The application allows quick entry without requiring user information, representing a user-friendly approach. However, a drawback emerges when we uninstall and reinstall the application, as our previous research is lost. Considering these advantages and disadvantages is our own project, we did not want to lose information on these search mimes, so we anticipated the need to retain user data. We wanted to enhance this by introducing the favorite function. I will now hand it over to Ekin to explain the next part.
Okay, thank you, Esra. From now on, I will be talking about the EDA section, which is exploratory data analysis. We applied exploratory data analysis for images to analyze the mine and mineral images for processing, image processing actually, to distinguish mine and minerals for our mobile application. We used EDA. In that case, we use EDA techniques for our data set to discover patterns and relationships within it. And EDA important because for data discovery, preparation, and for modeling, and for visual inspection and validation. As an example, we used Azurit class in mineral folder. Each image was further analyzed by separating its color channels. The values are visualized separately for blue, green, and red channels. These values are 0 for red, 1 for green, and 2 for blue. We achieved the results we wanted actually. In order to see the results of the data analysis more clearly, we showed them in histograms according to the color values. As it can be seen in the figure, Azurit is a blue mine, and blue color channel is specific identifier for it. When we apply the same technique to beryl class, which can be also blue and green in the nature, we saw that the green channel is more specific identifier for the mineral, which can be understandable from the frequency values. In the histograms, in the next slide, we will show their comparison. After we do a comparative analysis, it can be seen that there are differences in color profiles between Azurit and beryl class. We saw that the blue tones in Azurit class is more dominated than beryl, Also, both minerals have unique color features and characteristics. This simple color analysis is useful for distinguishing the visual characteristic of azurite and beryl minerals. Color values emphasize the separable features for both of the minerals, which is effective in making visual distinctions. Now, let's investigate the code for the EDA. We have used Python programming language for the analysis. At the beginning, we need to import the libraries. For images, we need to import Google Drive. And for image processing and reading the images, we have used OpenCV, CV2 library, and printing them as a histogram. We used matlab.plot. It is used for Python data for visualization, actually. The code is examining RGB values and printing them as a histogram. It effectively splits the images into RGB channels and flatten into the channels into one-dimensional array, then generates histogram for the channels, for the color channels, actually. This allows to visualize the distribution of RGB values for the set of images. To do that, we need to first load the images. Second, we extract the RGB channels for analyzing, and then flatten channels for generating histograms. We need to do it because plt.hist function requires a one-dimensional array. And at the last step, we use a loop to write the histograms, the title, and show the color channels for the final step. That's it for the EDA code. Now, my friend Utkan will talk about the machine learning for our application.
Thank you, Ekin. My name is Utkan Köktürk, fourth year Information Systems Engineering student. I am going to present you an early sample of our machine learning model. For creating a model and training it, TensorFlow, Keras, Matplotlib library, NumPy, and OpenCV was used. Here, in the first cell, we have used Image Data Generator class from Keras. This class performs real-time data augmentation on the images during training. The rescale that is inside the function call is for scaling the pixel values of the images. It divides the pixel values by 255, which is the maximum pixel value for RGB images. The same operation is done for the validation as well. In the second cell, we use flow from directory function to create a data generator for the training dataset. The first value inside the function is a directory that contains the subdirectories of our training images. Each subdirectory represents a class. Because this is a sample, we have two classes for classification. Target size specifies that all images will be resized to 200 by 200 pixels. The batch size determines the number of images to be loaded and processed in each batch. Class mode binary indicates that the problem is a binary classification task. For future, we may use categorical class mode because our classes will be more than 2. As you can see, the same operation is done for validation dataset as well. This cell defines a convolutional neural network using the Keras' sequential class. In the function call, there are 3 convolutional layers, 3 max pooling layers, 1 flattened layer, and 2 dense layers. The first convolutional layer has 16 filters of size 3 by 3. The input shape parameter defines the shape of the input images, which is 200, 203 for images of size 200 by 200 pixels and 3 color channels, red, green, and blue. The second and third convolutional layers follow a similar pattern with an increasing number of filters, 32 for the second and 64 for the third one. After each convolutional layer, there is a max pooling layer with a size of 2 by 2. This helps reduce the spatial dimensions of the feature maps. The flatten layer is used to flatten the three-dimensional output from the previous layer to a one-dimensional vector. This is necessary before passing the data to fully connected layers. The dense layer that comes after has 512 neurons. This layer is fully connected, and its purpose is to learn global patterns from the features extracted by the convolutional layers. Last dense layer has 1 neuron, and the output will be a probability score between 0 and 1, indicating the likelihood of the input image belonging to the positive class. Now, the first cell compiles the model that we saw in the previous slide. The loss function binary cross entropy is used for training the model in a binary classification problem. A different loss function will be used when the class number increases. RMS prop is an optimization algorithm. It is configured with a learning rate of 0.001, and the optimizer is responsible for updating the model's weight. The last one, metrics accuracy, which specifies that during training, the accuracy of the model will be monitored. The second cell is the training part. The first parameter that function takes is the train dataset. This is the data generator that we defined a couple slides back. The second one, steps per epoch, specifies the number of steps to yield from the generator before declaring one epoch is finished. It is set to 3, meaning that 3 batches of data will be processed in each epoch. The third parameter, epochs, specifies the number of times the model will be trained in the entire dataset. It is set to 15, so the training will be performed 15 epochs. The last parameter is the validation data. It takes the validation dataset, the same one we defined with the train dataset. On the right, you can see the 15 epochs and the accuracy of each epoch. This is the last cell of the code that performs the classification on images on the test dataset. The dir path variable holds the test dataset directory. The loop below iterates over the files in the directory. For each file, it loads the image using the image.loadimg function from Keras. The target size is set to 200-203. It means 200 by 200 pixels with 3 color channels. The image displayed using plt.imshow and plt.show functions. These 2 lines for visualization purposes. After the loop, first line img to array function converts the image to a numpy array. The line below adds an extra dimension to the array to make it suitable for input to the model. np-vstack function stacks the image array vertically. After that, model.predict function uses the model we trained in the slides before to predict the class of the input image. It returns a probability score. If the probability score is closer to 0, it prints pyromorphite. If not, it prints quartz. This is the output after the classification ends. Now, in the next 3 slides, you can see the code as a whole. And after that, my friend İnanç will continue on.
Thank you, Utkan. For our requirements part, we have come to a conclusion of what we will be using during the development. For the minerals themselves, we'll be doing our identification based on photographs, physical properties, structures, textures, and so on. Training datasets are all from Kaggle and Mindat. Our image processing tools will be TensorFlow, Keras, and OpenCV as they are the most available and convenient. Our application frameworks will mainly include React Native for front-end and Node.js with Django on backend. Our database will be made from MongoDB. GPT 3.5 will also be utilized for our brand new feature, allowing the app to write a poem or story with its own settings, however user wishes. For our ER diagram, we initiated a primitive approach to shape our project's design from scratch. Starting off with our mineral app entity, its attributes hold our mineral identification methods. data analysis results, and GPT 3.5 functions, respectively. It then connects to image analysis, image and photo in a one relation, as there can only be one result through their respective primary key IDs. Image analysis entity holds the result description attribute, which holds the mineral's details. Image and photo entities both hold the attribute that will determine the format of the picture, such as a PNG or a JPEG. Image analysis then connects to mineral entity in one-to-many relationship, as the name and the properties may or may not be multiple depending on the identification validity. Image and photo entities are both connected to data analysis entity as a one-to-many relationship, but in most cases it will be used as one relationship, as the application will allow one picture to be uploaded or taken. Data analysis then connects to mineral entity in an, again, one-to-many relationship, as analysis will provide multiple results and a batch of data. Photo and image entities also connect to the account entity, as that is where the images will be provided from. The account entity includes attributes that have user's name, email, favorites of the mineral, and password. This entity also connects to user feedback in a one relation, as they have the feedback they send is encoded within one feedback ID. It involves the ID of the user and the content that user has written in. The remainder foreign keys that I didn't explain you see here that aren't inherited from visible entities, because in reality, weak entities that didn't need to be described as they would just bloat the ER diagram and it would be really unnecessary to do so. Now, for our class diagram, we have expanded upon our design concept. We still have the same entity, but now in the new terminology sufficient for the diagram classes. Expanding upon the ER diagram, we now include our operations and even added several attributes to elaborate. All the relationships between the classes are the same as the ER diagram. The mineral app has the attributes and mineral identification that holds the result. Data analysis that has the processes of mineral being identified through data. And GPT 3.5 for the poem and story function. The operations are run app, which boosts up the app. Identify mineral, which gives you the result. Story and poem generation, which is done at user's demand. Users log in to have access to history and favorite features, and a register operation to allow adding their account in the first place. Mineral identification has the attributes image processor and mineral database that holds the database and processing of images. And as for the operations, it involves the identification of minerals and the aforementioned favorite function that allows you to save your favorite mineral that you have identified previously. GPT 3.5 integration class has the attributes for the settings. The user will have the ability to choose their language, quatrain amount, and genre options for poem, and length options and theme for story. The operations allow creation of poems and story through the preferred settings. Then we have data analysis class that has the attributes that involve the algorithm and collection for data with the operations that make the algorithm analyze the data and predict the mineral through the image. Mineral class has the name, properties, and images attached to from our data training and the operations that get us attributes. Photo and image classes involve their IDs and formats for attribute with the operations that get these attributes. The account class has the attributes of the user's name, email, password, registration status, and their favorites. The operations for the class involve ability to upload images or use the phone's camera to take a photo, leaving the history of the past identifications the user made. And the search bar within the history to immediately find what they desire with the right keywords. Last but not least, the user feedback class will have the feedback ID, user's ID, and feedback content. The only operation here will be the ability to submit the set feedback to us developers for consideration. And now, with that, I pass the presentation to my friend Çağlayan to continue with the system architecture.
Thank you, İnanç. Let's explain the system architecture briefly. That graphic you see describes how and where our application will be running on and by which softwares. There are three main system elements in the architecture. First, the development side, the team, which is us, and their development tools such as GitHub. We are going to handle the development, maintenance, and version control process there. And by a connection between our development environment and the server, which is the second main element in our system, the server will be updated and also the Android and iOS markets will do it. In the meantime, database will be updated by the users in the same server. We prefer to use Vercel as the servers and hosting software and MongoDB database management system within. Vercel is a good choice to keep and run JavaScript products because it is modern, reliable, and fast. MongoDB will be running by the control of Firebase backend framework. The third and last main element of the system is the mobile devices of the users. Users will download from Android and iOS stores by internet. After that moment, our front-end framework, React Native, will be running on the devices, and that will fetch necessary data synchronously from the server. Also, our key point of the application, image processing and machine learning libraries and algorithms written in Python, will be containing by its backend framework, Django, and it will be running on the server also. Now let's talk about UI and UX. All of the user interface components and screens are designed and have been drawn in Adobe Illustrator. We did not prefer to use any template from others, and they are coded according to the drawings as React Native component pages. We carefully coded them as relative design, and relative design means our designs will be running on every screen sizes and devices models. Moreover, as the same logic, the interfaces will be appear on both operating systems, iOS and Android, thanks to React Native. While we were designing the user experience design, we tried to be professional and scientific. You know, we always use the logic of make the product simple and the simple product be perfect. In every component design, we have used the specific Gestalt principles, that means human-computer interaction principles, such as symmetry, similarity, continuation, proximity, and closure. From that point, my friend Esra will continue with GPT integration.
And thank you, Çağlayan. I would like to provide a bit more detail about the GPT 3.5 integration we mentioned earlier. We are planning to add this feature to our project with the aim of bringing a new dimension to our application. Based on our user search result, we want to offer personalized poetry and or story options tailored a specific mineral. We plan to implement this feature using the ChatGPT 3.5 API. Users will have the opportunity to specify their preference such as language, length, and genre to obtain custom generated poetry or story. In this section, I will explain how to make a request to the OpenAI company, what the parameters will be, and provide an overview of the API. To begin, we create an account on the OpenAI website and obtain an API key, sending a request to the API requests, creating an HTTP post request, and within this request, we use parameters such as the model, prompt, token count, and format. When sending the request, we transmit the API keys, model name, and data containing our request. In line 1, we import the OpenAI class from the OpenAI library. For the line 2, we instantiate an object from the OpenAI class. This instance will be used to access the OpenAI using the GPT 3.5 turbo model. In line 4, call the API to make a chat completion using the model. We invoke the API to generate a chat completion using this model. We determine the model part in the fifth line, so GPT 3.5 turbo model. In line 6, this parameter determines the response format of the API. In this example, it ensures that the response is received a JSON object. JSON format is commonly used to structure and process data. The 7th line represented the beginning of the conversation. At the start of conversation, there are two messages with the roles of the system and user. The first system message indicates that it is assistant that can generate output in JSON format. The second user message asks a real user question. And in the last line, accessing the content of the response from the API and printing for the response in JSON format. I will now pass the floor to my friend Ekin to closing remarks.
Thank you, Esra. From now on, I would like to talk about the next steps, our application. We can call it feature plans. For feature plans, maybe we can add new features, maybe different functions to improve our project. As an example, maybe map integration, mine location determination, maybe, or it can be added to help to optimization, the resource management for professionals in mining industry and also for individuals. User community and data sharing system can be added to encourage people for communication. And lastly, price and size calculation functions can be good for our applications. And also adding more mineral classes for identification can be good for our project. That's it for our presentation. Thank you for listening, and thank you, my friends.
Thank you.
Thank you.
Thank you.
Thank you.